Bismillahirrahmanirrahim. Previously, I shared with you a postulate and theorems about parallel lines. That is, here we were given that lines were parallel. And we made certain conclusions about angles and when we had a transversal. If the lines are parallel, then we made certain conclusions about the corresponding angles, the alternate interior, exterior angles, and the consecutive interior angles. So in this scenario, we were given that the lines were parallel, and we made certain conclusions about the angles. And then last time we talked about theorems that were the postulate and theorems that were the converse of these. That is, we took this postulate and these theorems, and we talked about the converse. In this scenario, we were given some information about the angle, and we made certain conclusions about the lines. Specifically, we made conclusions that these were parallel lines. So these were all converse of the postulate and theorems that we had previously learned. So we had the corresponding angle postulate, converse, alternate interior angles theorem, converse, alternate exterior angle theorem, converse, and consecutive interior angle converse. So all of these we used to prove that lines were parallel. In this first scenario, we were given the lines were parallel, and we made certain conclusions about the angles. In this case, we used certain given information about angles to prove that the lines were parallel. So we had studied this. Last time, I had also shared with you two additional in one postulate and one theorem, in fact, and these were them. So we had the parallel postulate, which says if for a line in a point that is not on the line, there's exactly one line that passes through to the point that is parallel to the line. So if there's a line like this and there's some random point anywhere over here, then the parallel postulate states there's only one line that passes to that point that's going to be parallel to this original first line. And then finally, we had the perpendicular transversal theorem converse. This was another converse of a theorem that we had learned previously. Here, we are told that if two lines are here, L and M, if there are both of these lines are perpendicular to the same line. So we have two lines, and we were told that these two lines are they happen to be perpendicular to the same line like this. Then from this given information, which is basically about the angles over here, we can conclude that these two original lines are parallel. So this is the perpendicular transversal theorem converse. Okay, so stated more precisely, if lines are perpendicular to the same line, then they are parallel. So these are all postulates and theorems that help us prove that lines are parallel. Now today we're going to use these to do some example questions. And here is our first question, and instructions are written over here. So let's first read the instructions. Determine which lines, if any, are parallel. So our job is to figure out if any of these lines are parallel, given this is spelled paralleled. So this is actually given which are parallel. State the postulated theorem that justifies your answer. So we're supposed to go through these 6 questions with the given information, determine if any of these lines are parallel or not. Okay, let's see. So angle 2 and angle 8. I just wanted to bring to your attention over here, when I first drew this picture, actually, I made a mistake in copying the picture. I had 9, 10, instead of 11, 12, I had switched these around, and then I realized I made a mistake and went back and corrected it. That reminds me to tell you that you should be careful that you make sure that you read the question correctly, and you should also understand that there are certain scenarios like this when you have boatloads of angles and things like that given information, that there's a good possibility that one could make a mistake, and therefore you should be extra careful in how you try it and how you read and write the question. All right, nevertheless, so let's go on. So let's just observe the figure again. We have line A and line B, and line L and line M. That's only 4 lines that I see over here. And observe that these are labeled with lowercase letters, as lines are sometimes named. So lines can be named using lowercase letters. Okay, that's cool. And then we have a whole bunch of angles. Angle 1, 2, 3, 4. They go like that numerically, like a clock. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we got that. And we're supposed to figure out if any of these lines are parallel or not, and why. So we're here told in the first scenario that angle 2 is congruent to angle 8. Let's find angle 2 and angle 8. So here's angle 2 and here's angle 8. So that's interesting. So, and we're told that these are congruent. Now, can we use that to prove any of these lines being parallel? Well, well, these two angles are alternate interior angles, the way I see it, to these two lines. So here's these two lines, line A and B, and then here I have a transversal going through it like this. And these two angles are alternate interior angles, aren't they? So, and we're told that these alternate interior angles are congruent. So when two alternate interior angles are congruent, then these yellow lines here are going to be parallel. So from this bit of information, we can conclude that line A is parallel to line B. And here we're supposed to give our reason. So A is parallel to B because these alternate interior angles are congruent. Now we have a theorem about that, if you can remember. This is the alternate interior angle theorem, converse. All right, this is the converse, because the converse theorem tells us that if two lines are cut by a transversal such that the alternate interior angles are congruent, then the lines are parallel. Let me remind you, and here it is. Okay, so so here's our here's a theorem that we're going to use here. This is the alternate interior angle theorem converse. If two lines are cut by transversal such that the alternate interior angles are congruent, then the lines are parallel. So there we have it. All right. So so line A and B are parallel because of alternate interior angle theorem converse. Okay, the converse is what allows us to prove these lines to be parallel. Okay, let's go on to the next question. Angle 3 is congruent to angle 11. Okay, so where is 3? So we have angle 3 over here is congruent to angle 11. Okay, that's good. So we're told that these two angles are congruent. Now, what are they? How do they correspond? Let's see. Now, these two angles, angle 3 and angle 11, are not alternate interior, not alternate exterior, not consecutive interior, but these are corresponding angles, aren't they? Corresponding angles to this line L and line M, with this transversal being this over here. So that's the transversal. So those two angles are corresponding angles. So it's like this. So I have those two lines, and we're told that these two angles are congruent. So then from this we can conclude the following. Okay, so from here we can conclude that line L is parallel to line M. The L is parallel to line M, and this is because of the corresponding angle postulate. That's the only postulate, remember? Corresponding angle postulate, converse, right? So these are all the postulate theorems are going to be converse that help us prove the lines are parallel. So this is the corresponding angle postulate converse. So if two lines are cut by transversal such that the corresponding angles are congruent, then the lines are parallel. All right, so that's number 2 here. All right, let's see what we got in number 3. The question number 3 says angle 12 is congruent to angle 14. Okay, where's 12 and 14? So here's 12. Let's mark that here. It's angle 12, and here's angle 14. That's kind of interesting, huh? Maybe I'll erase some of the other ones so we're not confused over here. Too many things going on in one picture. So allow me to erase these for you, so we are dealing with only 2 angles at a time, so it doesn't become confusing. Oh, here we go. So we have angle 12 and angle 14. So they're pretty far apart, right? You wonder. So you have to see which lines you're going to use. See, after a while this becomes easier. So you're not going to use this line, right? Line L, because like sitting all the way over there. I mean, you can't use, for example, a line over there, a line over here. You have to use the line that's closest to these angles, right? So line L is not attached to these angles in any way. So but these are, there's a line A and line B, and then you have this transversal that's going through. Okay, that's the transversal. And if that's the case, then these are alternate exterior angles. Okay, see, if alternate exterior angles are congruent, if the alternate exterior angles are congruent, then these lines are parallel. So then we can say that we have to be careful. Line A is parallel to line B. So because this is alternate exterior angles to A and B with respect to the transversal M. A is parallel to B because of alternate exterior angle theorem converse again, right? So converse. Okay, ta-da, we got that. So alternate exterior angle converse. All right, let's see what we got next. Angle 1 and is congruent to angle 15. Okay, so angle 1 is congruent to angle 15. Where is angle 1 and angle 15? Whoa, well, angle 1 is over here, and angle 15 is over here. Now that's kind of tricky because here we have to assume that, you know, we don't have any of these. The question is not clear in that sense. In other words, do we assume all of these to be true to get to over here? Maybe, maybe not. But I think the way question is phrased, the way I read it, is that if this was the only information given to you, what can we conclude from there? Well, if angle 1 is congruent to angle 15, and that's like the only information given to us, okay, and let me put it. Let me put it like this. If that's the only information given to us, that these are congruent, we can't go very far because they're not alternate interior, they're not alternate exterior. They're like one is over here and the other one is like on the different plane altogether. You know what I'm saying? So there's no common lines between them. There's no transversal that connects both of these. Now we can't assume that 1, 2, and 3 are true. So if this was the only information given, you cannot make any conclusions based simply on this. So for example, 1 and 9 would be consecutive corresponding angle. 1 and 10 would be alternate interior. 1 and 11 would be alternate exterior. 1 and 15 are just two separate angles in two different parts of the world. So here you cannot make any conclusions the way I appreciate it. So you can't make any conclusions from that bit of information that's given to us. Okay, now what? Measure of angle 8 measure of angle 13 equals 180 degrees. Okay, so where is that? So that's 100. This is 8 and 13. So we told that angle 8 plus angle 13, so these add up to 180 degrees. Well, if they add up to 180 degrees, that's basically another way of saying that these are supplementary, right? So, while they're supplementary, how many theorems we know about supplementary? Well, these are consecutive interior angles, the way I see it. So here's one line, here's the second line, and here's the transversal, and these are consecutive interior angles. Okay, so if the consecutive interior angles add up to 180 degrees, then the lines are parallel, right? So this is then we can say which lines are parallel. These are consecutive. 8 and 13 are consecutive interior to L and M. So we can conclude that L, let me write it this way. Alright, so I'm sorry about this. So we can say L is parallel to M. Alright, L is parallel to M because of the consecutive interior angle theorem converse. Okay? Let me write that neatly over here. So we said L is parallel to M, and this is because of consecutive interior angle theorem converse again. All right, consecutive interior angle theorem. And the last question here is angle 8 is congruent to angle 6. So angle 8 is congruent to angle. So these two are congruent. Now this is tricky again because if that's the only information given, we can't assume that the rest of the information. So if these are congruent, what conclusions can we make? Well, how are these 8 and 6 related? Well, they're not like, you know, alternate interior, alternate exterior, consecutive, or corresponding angles. They're simply vertical angles, and we know that vertical angles are congruent. Well, Yeah, they're congruent. So these are vertical angles, and they're congruent. We know that vertical angle theorem, right? So these are vertical angles, but you can't use that to prove any of these lines being, being parallel. So the question was determine which lines, if any, are parallel. So we know vertical angles are always congruent. You know what I'm saying? That doesn't prove any line being congruent at all. So if that was the only piece of information given, we cannot make any conclusions from here. Okay, you can't make any conclusions from those two questions, number 4 and number 6, but the rest you can use to prove that those lines are parallel. So this is our first questions. Okay, let's see what we have next. Okay, it looks like our next question is an algebra question. Let's read our instructions first. Find the measure of angle MRQ. So the MRQ. So there's M, there's R, this point of intersection, and there's Q. Okay, so and angle MRQ is this angle right here. Well, it's a fancy way of naming the angle, but that's cool. Okay, so equal opportunity angle naming. Okay, so that's this angle we're talking about. MRQ is that angle. So we're asked to find the measure of that angle so that A is parallel to B. Where's A and B? So here's A and B. So we were told what does this angle have to be for A to be parallel to B. Identify the postulate or theorem you used. Okay, so in other words, what does this angle have to be for these lines to be parallel? Okay, well, so if A and B are two lines, and this line C is a transversal, and we're given these two angles. See, we're given this angle in terms of x, and we're given that angle in terms of, well, how are those angles related to the lines A and B? Well, they are alternate interior angles, aren't they? So these are alternate interior angles. And if the alternate interior angles are congruent, then the lines are going to be parallel because of alternate interior angle theorem converse. Ta-da! Very good. So the theorem that we use is going to be a theorem. It's going to be the alternate interior angle theorem converse. I'm just going to converse. Ta-da. Okay, so we're going to use that. If two lines are cut by a transversal such that the alternate interior angles are congruent, then the lines are parallel. Okay, so using that theorem, and if these two angles are congruent, then the lines will be parallel. Okay, so then we say, well, then 5x plus 7 has to be equal to 7x minus 21. So if these two angles are congruent, then the lines will be parallel. Well, we don't know the exact measure of the angles, but they're given them in algebraic form because, they want us to do some algebra. Cool, we can do some algebra. So, but if these two angles are congruent, then the lines will be parallel. Okay, now we just have to solve for x. Okay, how do we solve for x? So I'm going to gather the variables. So if the variables are on two separate sides of the equation, we collect them and bring them to one side because we're solving for the variables are in all different places geographically, to be able to solve them. So bring them all together. So this cancels out. So then we have 7 is equal to, that's 2x minus 21. And I bring the 21 to the other side because we're solving for x. So then I get, this cancels out, 7 as 28 equals 2x, and divide both sides by 2. Then I get x is equal to 14. Now, you have to be careful because small children, they come to the step and say, they found the x, and then they stop, and then they go on to the next question. They rectangular, they box the x and say, I got it. But the question didn't ask for x. The question asked for the measure of the angle, right? So, okay, fine. So how do we find the measure of angle? So the measure of angle MRQ, notice these are all capital letters because they denote points, and points in geometry are labeled using capital letters. Okay, so that's cool. So the measure of this angle is going to be 5x plus 7. Then all we have to do is substitute here 5 times 14 plus 7. So that's 70 plus 7. Now 5 times 14, that sounds like a heavy duty math, right? But multiplication by 5 is kind of easy in a way, because 5 times 14, what I do is I actually do a 10 times 14. So 10 times 14, and that's going to be 140, and then you divide by half because this is 5. So in your mind, sometimes you can just, if that's 10 times 14 is 140 divided by half is 70. Or you can do this. So 5 times 14 is the same as 10 plus 4. That's 50 plus 5 times 4 is 20. That's 70. Okay, so this is mental math. I hope you appreciate that. And sometimes you can't rely on your calculator to do every single thing. It's like 2 times 5. You put that in the calculator. I'm saying you got to train your mind a little bit. So anyway, so 5 times 14, that's 10 times 14 is 70, divided by 2 is that 140 divided by 2 is 70. So that's 70. So this angle ends up being 77. So the measure of this angle is MRQ is 77, and that's actually the answer we were requested to find. 5. Now, if this angle is 77, then if you put the x in here too, this will end up being 77 also. So these both will, if you substitute 14, that is, in this here, this angle also ends up being 77, and those will be congruent, and therefore the lines will be parallel. Okay, so this question was a nice algebra question. Let's see what we have next. Okay, so we're given E and F over here, line E and line D. Find Y so that E spells elf, doesn't it? It looks like elf, but anyways, parallel. E is parallel to F. So find Y so that E is parallel to. For these to be parallel, well, that's very interesting. That's a 90-degree angle. And if that's 90-degree angle, what is this? Are these alternate interior angles, this 90 degree, and this one? No, they're not. The alternate interior would be these two, okay? So let me just say, let me just label angle 1 and 2 here would be alternate interior. How about alternate exterior? Are these alternate exterior? No. Angle 1 and 2 over here would be like alternate exterior. Okay, so they're not alternate interior, not alternate exterior. They're not consecutive interior. They don't seem to be related at all. Okay, well, let's just find Y so that E is parallel to it. Well, this should remind us of this theorem, the perpendicular theorem that had to do something with the perpendicular lines, right? That theorem, this one over here, the perpendicular transversal theorem, Converse. This theorem said that if you have two lines that are perpendicular to the same line, then they are parallel. If lines are perpendicular to the same line, then they're parallel. This is the perpendicular transversal theorem, Converse. Okay, so that's cool. So let's see what we got here. We use that theorem here, perpendicular transversal theorem. Well, if we use the perpendicular transversal theorem, if you make this to be perpendicular like that, then those lines will be parallel, won't they? Okay, so yes, if that's the case, then if this angle here is 90 degrees, well, then this is going to be 90 degrees, right? You know what I'm saying? Because a perpendicular line creates 4 right angles, right? We know that. That's a theorem that we studied before. Okay, so if this is 90 degrees, then these two lines will be perpendicular, or then be parallel. You will be parallel to F. Okay, fine. So that's 90 degrees. If this is 90 degrees, if two lines are perpendicular to the same line, then they're parallel. Okay, so there we go. So all we have to do is 4y plus 10. If that many degrees, this angle over here, if that is equal to 90 degrees, then those two lines will be parallel. Good. All we do is solve for y. So 4y is equal to, subtract 10 from both sides, that's 80, and then divide by 4, that's 20. So y is 20, and that's it. That's too easy almost, it seems like, you know what I'm saying? But there's no trick over here. So y is 20. 20 times 4 is 80. Well, that pretty much seems like it. That was not tough, okay, hopefully. All right, so done. All right, I think we have maybe one more question or so. So let's see what we got. Ooh, it looks like we have a proof over here. Okay, so, fine, let's read the question. Given angle 1 is congruent to angle 2. Okay, so angle 1 is congruent to angle 2. And then we're asked to prove that line L is parallel to line M. Wow, this is like the alternate exterior angle theorem, right? You know what I'm saying? If two lines are cut by transversals such that the alternate exterior angles are congruent, then the lines are parallel. This is, in fact, the alternate exterior angle theorem. So can't we just say So this is from the alternate exterior angle theorem. No, here they're actually asking us to prove the theorem. So we're actually asked to prove this theorem. Remember, theorems can be proved, okay? So here we're going to try to prove the theorem itself using other knowledge that we have learned. So here are going to be the statements, right? And at the end, statements. And here are going to be the reasons. I love this. All right, so the first statement is the given information. So angle 1 is congruent to angle 2. There we go. So this is because of given information. Ta-da! That's easy peasy. Now what do? I'm stuck. All right, now, so here we go. Angle 1 is congruent to angle 2. Okay, that's given. What can we do? What can we do? What can we do? Well, somehow it looks like I'm going to have to use the angle 3, right? Angle 3, angle 1, no, angle 3. Okay, so well, angle 3 and angle 2 are like vertical angles, right? So they're congruent. That sounds like a good thing to put here. Okay, so I'm going to say angle 2 is congruent to angle 3. Why? Because, you know, these are vertical angle theorem, right? They're vertical angles, and they are congruent. So I can just say vertical angles are congruent. There you go. That's a theorem. Vertical angles are congruent. Okay, that's a theorem. Okay. Now, and then, I don't want to put a T there because that sounds like true. That's a theorem. So you can just write vertical angles are congruent. Okay. Now what? Well, angle 1 is turned. Okay, now look. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, that sounds like, oh, a transitive property coming up to me. Because if by transitive property, angle 1 is going to be congruent to angle 3, because if A is congruent to B and B is congruent to C, then, right? So this is the transitive property of congruence for angles. Ta-da! Oh, I like this. I like this. So I'm going to say this, okay? I'm going to say angle 1 is congruent to angle 3. Why? Because this is from the transitive property of congruence for angles. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. That's the transitive property of congruence for angles. That's beautiful. And finally, then, now we know that 1 is congruent to 3. See, now we know that this is congruent to this, right? Because we proved that. So, 1 being congruent to 3, 1 and 3 are corresponding angles, aren't they? So then we can say, and the following. I'm going to say that's going to be 4. Then we can say 1 is congruent to 3, simply that line L is parallel to line M because of corresponding angles postulate. Corresponding angle postulate converse, right? So that's the only postulate, remember, of the stuff that we learned in the first set. So the corresponding angle postulate states that if two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel, and that is that. All right, so that's QED. All right, proven. Now, so I think that is all I have for you today. Inshallah, next time we shall do more and elaborate on this knowledge that we have learned. Until then, as-salatu was-salam ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.